Hi, we're back with the end of chapter 4. So we're going to be working on the rest of the fractions chapter. And we are starting with 4.5, which is adding and subtracting fractions with different denominators. So this is where we're really going to get into that butterfly I was talking about last time, because now we have adding and subtracting with different denominators. So before that, I want to just go the way that you've probably always been taught, with the least common denominator. And the least common denominator we've actually talked about before. We just called it the least common multiple. And so some people can look at 9 and 6 and they automatically know what the LCD is. However, if you're not sure, remember we could make that cake method I was talking about in a previous chapter. So I write down the 9 and 6, and then I notice that they have a 3 in common. So I'm going to say 3 goes into 9 3 times, 3 goes into 6 2 times, and then the 3 and the 2 down here have nothing in common. So I'm going to make my L. The L is for the least common multiple, or the least common denominator. And then I multiply all 3 of those numbers, 3 times 3 times 2, which equals 18. So what we're saying is 9 goes into 18 and 6 goes into 18. And that's the smallest number that they both go into. All right, so trying it again for number 2, we have, it's telling us that 24 is the LCD for the fractions 3/4 and 5/6. And then we want to know if that statement is true or false. And so certainly if you multiply 6 times 4, that does equal 24. But as you see above, the answer isn't always what happens when you multiply the denominators. Because on number 1, if I multiply 9 times 6, I would get 54, but we could see that the answer is much smaller than that. So we do need to check for what the LCD is between 4 and 6. So 4 and 6 have a 2 in common. That leaves me with a 2 and a 3 left over. Multiply all 3 numbers, or however many numbers are in the problem, and we get that 2 times 2 times 3 equals 12. So this statement is false. 24 is not the LCD of those two fractions. The actual LCD is 12. All right, one last practice with this least common denominator cake method. We have 10 and 15. They have a 5 in common. So that 5 goes into 10 2 times. 5 goes into 15 3 times. I'm done. So I'm going to multiply. I'm done because 2 and 3 have nothing else in common. So I'm going to multiply those together, and I get 30 as the LCD for number 3. All right, now we want to work on converting fractions if they give us the LCD. So number 4, it's telling us that 30 is the LCD. And so what I want to do is I want to make these equivalent fractions, or I want to find fractions that are equivalent to them. So this is a 2-part problem. I have 5/6 that I want to make over 30, and I have 4/5 that I want to make over 30. So I'm just looking for that missing numerator. And so on the first fraction, since 6 times 5 is 30, we're going to multiply the numerator by 5 as well and get 25. So that would be our first answer. And then 4/5, well, 5 times 6 is 30. So 4 times 6 is 24. This is the opposite of reducing. So we want to make sure we have that 1, 6/6 or 5/5 that we had earlier, because we can always multiply a fraction by 1 or divide a fraction by 1 and keep the equality. Okay, next one, last one with the LCD, And in fact, when we get to the bottom here, or to number 6, we don't even need the LCD to do these problems, but I like to practice the LCD because that's the way you're familiar with, and you might not like my new way, and you might want to just do it the way you know. All right, so we know the LCD is 24. So 3/8 equals how many 24ths? And 1/6 equals how many 24ths? Well, 8 times 3 is 24. So I'm going to multiply the numerator by 3 and get 9 for my first fraction. 6 times 4 is 24. So I'm going to multiply the numerator by 4 and get 4 over 24 for my second fraction. Okay, so we have all the tools, and I will do this first one with the LCD just to remind you how it's done. But then I will start using a different method as we go through this, just to give you something different to try. We only have a couple here. Okay, so this first problem, so we have to put everything together that we just talked about. We have an 8 and a 12, and it doesn't really matter the order you write them in to find the LCD. I tend to write the smaller number first, but you don't have to. And you decide what you think they have in common. Some people will see a 2 right away because they're even, and other people will see a 4, and it doesn't matter. I'm just going to do the 2 just to remind you that you can do this multiple times. So 2 goes into 8 4 times. 2 goes into 12 6 times. And then since 4 and 6 have something in common, I'm going to do this again. 2 goes into 4 2 times. 2 goes into 6 3 times. And here is my L because 2 and 3 have nothing in common. Notice if you recognize that 4 right away, you would have still had that number 4. 2 times 3. 2 times 2 is 4. So whether you wrote a 4 or whether you wrote 2 times 2, you would have had the same answer either way. All right, so 2 times 2 times 2 is 8, times 3 is going to be 24. So our LCD is 24. So I have 5/12, and I'm adding 3/8, and I want both of them to have a denominator of 24. And so the bottom fraction I multiply times 3. The top fraction I multiply times 2. And finally, I add those together, and I get 19 over 24 as my final answer. I would have to reduce that if possible because the instructions say to simplify. However, 19 doesn't have anything in common with 24, so that's all I can do. All right, so I'm going to move on to C next, just to try this butterfly method. And again, you might like this, you might not. I probably hyped it up a little too much at this point, but that's okay. We're going to roll with it. So what we're going to do is make our butterfly from before. In fact, I'm going to zoom in a little bit to make it a little bigger. And we have our wings. And so we've talked about before how we're going to multiply and write the number on the top of the wing. So 2x times 3 is 6x. And 2x times 9 is 18x. You always want to write the number on the top of the diagonal. And all good little butterflies have a little antenna. How pretty that is. And then finally, they have a body. So here we're going to multiply those 2 that I just touched, 9 times 3, and get 27. All right. I have all the numbers I need. I have not found an LCD. I just kind of multiplied a bunch of stuff together. And now, since this is an addition problem, I'm going to add 6x plus 18x, which is 24x, over my denominator of 27. All right, I think my pen's cutting out because I zoomed a little too far in there. But now I have 24x over 27. This is multiplication on top. So I can reduce. We see that 3 goes into 24 8 times, and 3 goes into 27 9 times, and so the final answer is 8x over 9. So the moral of the story is you pick the method that you like better. So I'm going to do one of each again, just to give you practice in both methods. And I want to kind of talk about the pros and cons. So on part B, if I drew a butterfly, I would have to be multiplying 21 times 9, 14 times 13, and 14 times 21. And those are all really big numbers. So sometimes it might just be faster to get the LCD because it'll create less reducing in the end. So 14 and 21 have a 7 in common. That goes in 2 times, it goes into 21 3 times. And so now I have 7 times 2 times 3, which equals 42. So I'm going to write out this fraction, or this subtraction, 9/14 minus 13 over 21. And I want them both to be over 42. So I have to multiply 21 times 2. And I have to multiply 14 times 3 in order to get to this answer. All right, so 13 times 2 is 26. 9 times 3 is 27. And so I'm going to subtract 27 40-seconds minus 26 40-seconds, and I get 1 over 42, 1/42 as my final answer. Remember, addition, subtraction, you don't touch the bottom number. The denominator will stay the same once you're actually ready to add and subtract. It is just the numerators that you're adding and subtracting. And so, of course, we would have to reduce if that was necessary in this problem, but it's not, and so we are done. So looking at D. Now, if I look at D, 7 and 5 don't have anything in common. And these are pretty small numbers, so multiplying isn't gonna even require a calculator here. So I have 25, and multiplying this way, 7 times 3x is 21x, and then the body, 7 times 5 is 35. And so really the main trick, I guess you could say, on this problem is to recognize that the numerators are not like terms. So you can't even put them together. You can't even combine them. All we can do in this problem is write 25 minus 21x, because they don't go together. They're not both x's. And therefore, the denominator is 35, and we are done with that problem. So be mindful of where your variables are. In part C, there is an x on both numerators, so I was able to combine them and add them together in that instance. In part D, they did not both have an x, therefore I did not have like terms, and I had to leave them separate as 2 terms in the numerator. Okay, and that is it for 4.5. So what I want you to do is figure out which way you like better. Do you like the L, the little cake thing? Or do you like writing out a list of factors? Do some people just look at it and they know the LCD of 12 and 8 just by looking at it? Do you like the butterfly, or do you like converting each fraction? You know, you don't even have to answer these questions. You can change your mind on every single problem like I did. So just figure out what works best for you and work through 4.5 homework while we pause the video to get ready for the next section. And we are back with 4.6, adding and subtracting mixed numbers with common denominators. Now this section is pretty short. Look at that. There's only 2 examples. However, I thought that it was important to bring this section up because you do things with mixed numbers in your life. Maybe you cook. Maybe you add measurements to go to Home Depot and buy something. I don't know, whatever you do. People use mixed numbers all the time. I didn't feel it was so important that I wanted to beat you over the head with it. So I just chose the section with common denominators. If this was real life, your denominators might not be common, but we just saw in the last section how to deal with that. And so for the purpose of what I want to get out of this class, I just put the mixed numbers with common denominators. All right, so first one, find the sum. And you know how to add fractions. We just did that. What I really want to focus on here is how to carry or borrow with mixed numbers and when it's necessary and when it's not necessary. So for the first example, we have 4 1/6 plus 3 5/6. And when I say that, I'm saying the and in between because it's kind of it's the partial part of the number. And so what we can do here is we can add the whole numbers, and you don't necessarily need to write this down every time. This is just what you're thinking, but I like to write it down at least the first time to see what's going on. So we have 4 plus 3, and then we have 1/6 plus 5/6. So I'm just rearranging how everything's written, and I'm grouping together the parts that will be added in our head easier. All right, so 4 plus 3 is 7. And then 1/6 plus 5/6 is 6/6. So really this problem is 7 plus 1, which equals 8. Okay, not too shabby. It's not always going to be that easy where we have that 1, but we can kind of use that idea to see how we're going to carry. And so here we are thinking 7 plus 6 and 4/7 plus 5/7. So here we have 13 plus 9/7, and that is not going to work. That is a mixture of a mixed number and an improper fraction, and we cannot have that. So I'm going to change my 9/7 into a mixed number. And we've done this a bunch of times in the last module. We can even do the division in your head if you feel comfortable with that. 7 goes into 9 one time, and then there's 2 left over. And so this is how we carry. We have that same concept of carrying with the fractions. We're typically realizing that the fraction itself is more than one whole. And so I want to take that one whole and put it with the other whole numbers to make 14 wholes and 2/7. All right, finally, I'm going to not write the thinking step on this problem because the goal is to just be thinking it and not writing it down. But adding the whole parts, we have 2 plus 5 is 7. And then adding the fractions, we have 5/9 plus 7/9 is 12/9. 12/9 is 1 3/9. So I'm going to add the 1 plus 7, which is 8. And since I have to rewrite it anyways, this is the perfect time to reduce that fraction. So 3/9 becomes 1/3. It didn't explicitly say simplify, but it's just a life skill to know that you always write your fractions simplified. That's just how they always want to be written. So even though it didn't explicitly say it, you're going to want to reduce your answers for all of these problems that it's necessary. Okay, so that is what carrying looks like with mixed numbers. Now let's look at what borrowing looks like with mixed numbers. Okay, so I have 8 4/7, and I'm taking away 3 5/7. And I can't just move things around as easily because of that subtraction sign. So before I could just add stuff and added it in the order and it didn't matter because it was all addition. But since we're subtracting, it doesn't work that way. So I'm going to write it off to the side. 8 4/7 minus 3 5/7. And what I'm doing is I want to borrow 1 whole for this problem, and you need to think about what 1 whole equals, because I can't just put a 1 right here, because it's not really a 10 that I'm borrowing, it's a 1 that I'm borrowing. And so in this example with sevenths, that means I borrowed a 1 and I made it a 1. I should not do that, it should be a 7. I borrowed that 1 and I'm giving it to the fraction, and so it is 7/7 because that would be 1 whole. And so I really have the problem 7 11/7 minus 3 5/7. And that's a really awkward way to write it, but the reason we have to do it that way is because the top number has to be bigger. So subtracting 7 minus 3 is 4. 11/7 minus 5/7 is 6/7. All right, that was kind of clunky. I don't know if you guys like that or not. So I will show you another way in case that borrowing doesn't really make sense. But luckily on part B, we don't have to borrow, because if you do it in your head, you could see that the first number is bigger than the second number. So we won't have to borrow. We just have 11 minus 7. Well, I'll still write it out. We don't need to do it in our head and get messed up. 11 5/6 minus 7 1/6 is 4 4/6, but we can't write it like that. So we will reduce it to 4 2/3. So I subtracted the whole numbers, I subtracted the fractions, and then finally I had to find a reduced version of the 4/6. Okay, a quick assessment of C, and I realized that this is going to be some kind of borrowing problem again, because the 4 minus the 7, that's going to give us, we can't do it that way. So another way to do this, if you didn't like the borrowing method, which I totally get if you don't like that, is to just make improper fractions. And so 6 4/9, we know how to make this improper. Multiplying 9 times 6 and then adding 4 gives us 58/9. And then multiplying 9 times 4 and adding 7 gives us 43/9. And now all we have to do is take 58 and subtract 43, because they have that common denominator, and we get 15/9. Not quite to the answer yet, because if the question has a mixed number in it, we want to have our answer have a mixed number in it as well. So I'm going to rewrite this as 1 6/9. And finally, reducing that to get 1 2/3. And so sometimes that feels a little longer, because we had to turn it into an improper fraction to subtract and then turn it back into a mixed number. And so people find that extra step a little too long. However, other people really don't understand what I'm talking about when I say borrowing. And so if you are in that boat, then by all means do this more straightforward method. Even if it takes a little longer, it is at least consistent. And every time you just change it to an improper fraction, subtract, and then change it into a mixed number. All right, well, this is going very quickly. Finally, right? You're like, oh my gosh, how many long videos do you possibly make? All right, so break time, pause the video, get a snack, do some homework. I'll be here when you get back. And we're back, and we are focusing on equations. So I mentioned at the beginning of this course that one of the main things to talk about in pre-algebra is solving equations. We have done it with whole numbers, we've done it with integers, and now we're going to do it with fractions. And there's two parts to this. because the addition, subtraction, and division properties are all pretty consistent with what we've done before. However, the multiplication property is a little different, so because of the fractions. So first we're going to determine whether 1/3 is a solution. So as a reminder, we're just going to rewrite the problem, and every time you see an X, change it into a 1/3. And what we are asking is the left side equal to the right side? So I put a little question mark on that. And then I just work through this problem. We've done plenty of order of operations problems. I'm just going to work through the left side independently of the right side. So multiplication first, 9 times 1/3 is 3. And if that wasn't quick for you, if you're trying to figure out what I just did, remember that 9 is really over 1. So it's 9 over 3, which becomes 3. Plus 14, we get 17 on the left side. And now we're going to do it again on the right side. 19 minus 6 times 1/3. Remember, just write the 6 over 1. Then multiply across the top, multiply across the bottom, and we get 2. 19 minus 2 is 17, which is equal to 17. So yes, x equals 1/3 is a solution to this problem. All right, so now that we've figured out what a solution looks like, we are going to solve on our own. And so I just put one example of each method because we have done this before. The only difference is there are now fractions involved. So I'm going to subtract to get the 0 pair on the first problem. And so really the difference is just the added rules that come along with fractions. So I have a common denominator. I want to subtract 5 minus 7, gives me a -2. And then finally I want to reduce, and so I end up with x equals -1/6. All right, part B, I'm going to add 5/4 to both sides. That gives me the 0 pair, which cancels out. And I get y equals, and I have, so this, we have the -3/4 and the positive 5/4. And so we could just think of that as 5/4 take away 3/4. Or if you prefer, just move that negative up to the top. Not right.